So, I managed to get FreeBSD USB stick image written into a stick. And in order to do that, I had to use a FreeBSD laptop because the main rig I have has Windows 10, and trying to write a memory stick image on a USB stick just doesn't work there for some reason. It always produces a corrupted image. This is why I think Windows sucks. While in the FreeBSD it was as simple as using the dd command to write a sector-to-sector copy of the memory stick image into the memory stick. That's how simple it was. So yeah, fuck you Microsoft, fuck you Windows. People should use Linux and FreeBSD if you can. It's these systems don't get in your way that much. There's less fuckery going on in the background. But anyway, what I was going to do now is to install FreeBSD. So I just booted the memory stick and it went into the FreeBSD installer. From here on, we can use arrow keys, enter and tab to navigate these different menus. And here we choose install and press enter. Now it asks us to select the keyboard layout, and we will be choosing the United Kingdom layout here. I just know it's correct, so then we choose continue with uk.iso.kbd keyboard and press enter. Enter Wings as hostname because, well, it's the label that's imprinted in the front of the computer chassis, so whatever. And then we can choose optional components. We will use space key here to select and deselect these different components. So we go to ports and press space to deselect it. We don't need ports, we will not be compiling any software on this machine. We just don't do it, it's kind of slow and this machine is old, not worth it. Next we're going to go use arrow keys to go to dock and press space to select it, because we want the documentation. It's the most important part of the system, the documentation. Without documentation, if something comes up, we don't know what to do, so we want that. After we've done our selections, we just press enter. And then we go to the next part. Now here we want to do manual disk setup because we have an old computer that I can only boot from MBR, partitioned devices. We select manual and then we press enter. Okay. Here we can see we have ADA0, which is an MBR disk. And we choose this and then we use arrow keys to navigate the selections on the top bottom, and we choose create and press enter. We create a FreeBSD primary partition. By creating a FreeBSD type primary partition, first of all it enables the installer to actually operate on the partition, and secondly it notifies other operating systems, if I had such installed in the system, that do not touch this partition. It's FreeBSD specific and so forth. Okay. And press enter. Now we have a FreeBSD specific primary partition. In order to actually create file system on the partition here, we need to create a sub partition, and in FreeBSD slang, the BSD labeled primary partition is called a BSD slice, right? It's a slice. A BSD labeled primary partition is a slice. So we have here a FreeBSD BSD slice, and we select it and go to create and press enter. And now we can create a FreeBSD partition into the FreeBSD slice, right? It's basically a sub partition. We set the type first to FreeBSD UFS, because this is the partition type we want, and the size will be actually, now we need to take into part that we need a swap partition here, so we will have to modify the size of the FreeBSD UFS partition, which is the file system partition. So we will need a 4 GB partition, so I think we need to subtract 4 from this. Let's subtract 5 just in case. So 9 minus 5 is 114. Okay. And now the mount point we will be using is forward slash. That means it's a root partition. This is important. If we don't put forward slash here, the installer won't be able to determine where it should crap out all the system files. So we put here mount point forward slash and then go to use the tab key to go to OK and press enter. Okay, now we have 414 GB FreeBSD UFS partition on the BSD primary partition. And next we will we'll choose again the BSD slice, and we go to create and press enter. And now we will create a FreeBSD swap. To do that, we press tab key a few times so we can get the cursor into the top part here. We go here and we set the type to FreeBSD score swap, like this. We don't see to we need to set this blank for swap. As you see here, it says blank for swap. Good. And now we press tab, go OK and press enter. Okay, now we have around a 5 GB swap partition and 114 GB root partition. And basically we can set the cursor to just about anywhere, but traditionally I set it on the FreeBSD UFS partition just in case. It doesn't really matter, I could put it anywhere. And then I go to finish and press enter and then press commit. Now it copies all the distribution files into the root partition. This includes the base, which has all the utility binaries, and it includes the kernel, which goes under /boot, and the doc, which is documentation. Now it prompts us for root password. This is the root user, which is important for maintaining the system. Okay, now it wants to configure network interface. It found that we have the Intel yada 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 at ICH 6. We press enter here. Would you like to configure IPv4? Yes. Would you like to use DHCP to configure interface? Yes. Now it will be acquiring DHCP lease. This will take some time. Would you like to configure IPv6 for this interface? No, we don't use this in this network. So we use arrow key, select no, and press enter. As you can see, these are the parameters, these here, that it found out by acquiring the DHCP lease. the DHCP server told the DHCP client that these are the things, and it recorded them in a file, and the installer read them, and now it presents them here. We just only have to approve them at this point, so I press tab and OK and enter. Is the machine MOS clock set to UTC, which is the Universal Greenwich Time? No, we actually use local time on the system clock, so we go to no and press enter. Normally we always use local time in personal computers. If you have a huge like mainframe installation, a server or infrastructure machine that you use to synchronize, share synchronized time to a network, and then you would probably press yes here, and you would have preemptively set the BIOS or system setup firmware time into UTC. Okay, that's when you would choose yes here, but because we're just using a single computer, we choose no and press enter. Okay, now it prompts to select a region. We select Europe and press enter. And we select Finland because that is the country where this computer happens to be in right now. And this sets all kinds of properties in regards to how messages and units and measurements and whatever are presented. So we choose Finland. Does abbreviation EET look reasonable? I guess, yeah. Doesn't really matter. Time and date is correct, so we skip this by pressing enter. Time is correct, skip enter. We can choose services. We definitely want to press go to NTPD and press space to select NTPD because we want to synchronize time as often as possible. It's useful. PowerD, I checked the specifications of the machine. It doesn't have the CPU FREG support. These old processors, Pentium 4 processors, didn't have that. Some of the newer Pentium 4s, maybe the latest models, might have had this, or the mobile models had this, the Pentium D processor, but this doesn't, so we disable PowerD, we don't enable it, it's useless. And mouse D, nah, we don't really need mouse pointer and console, so we leave it disabled. So now we press enter. Here we can harden the system. This entirely is dependent on how you want to use the system. If you want to set up multi-administrator machine like network root point, you probably don't want to disable send mail service because the send mail service might be used to deliver system reports to specific administrator accounts and stuff like that. In my case, I've never found any use for send mail. I normally configure a simple SMTP agent or some other system to deal with system reports and stuff like that. So I will just disable send mail. And here we can choose if the syslog-D opens a network socket, so you can connect to the socket and read the logging information. Normally, I think even if you leave the syslog-D to open the socket, it still would require, I think, IP or ARP-based authentication on from which IPs you're allowed to connect to the socket and stuff. So it is still somewhat secure, I think, not sure. But in my case, I don't need this remote locking, or if I do need that, I will set up a specific daemon for it and configure it myself. So I will just disable locking, network remote locking. Clean TMP file system startup. This is pretty smart idea. Always. You should at least enable clean TMP file system on system startup. removes clutter. Yeah. Insert stack guard page ahead of growable segments. This option is to prevent some buffer overflows, whatever. We'll leave it out because I don't think we'll need this option here. Randomize speed. Okay, that's good. We'll enable it. Okay. Hide process running as other users, hide process running as other groups. In this machine, we'll be having only one normal user, so none of these accounting security options aren't really necessary, so we'll leave them as is and press enter. Okay. Would you like to add users to the installed system now? Well, we could. Maybe we should do it now so we can show how this whole user accounting works via the BSD install utility. I haven't even visited this myself for years, so alright, yes. Okay, now it asks for username. We select BOFH, bastard operator from hell, if you know the Usenet legend. Okay, now press enter. Full name, bastard operator from hell. Enter. UID leave empty for default. This is good. Login group BOF. Invite BOF into other groups. We will set wheel here so that we can actually use su, substitute user, or sudo later on to gain root privileges. This is useful. Login class default, yes. We can use all kinds of shells here, but we will just choose sh. It's a very, very simple shell, but it's usable. Password-based authentication, yes. No empty password. No random. Okay, password is put there. Logout. Okay, yes. Add another user, no, and enter. Cool. Now we can here do some other stuff. We can basically revisit the some of the previous options that we set. But now we are mostly done, so we just choose the exit, apply configuration, exit, installer, press enter. Installation is now finished. Before exiting install, would you like to open shell in the new system, make any final manual modifications? No, not really. So now we will just reboot. Okay, I went to BIOS setup because now I want to configure the Plex Store as the first drive so that it boots from the Plex Store SSD instead of the Kingston Data Traveler. Yes. Let's press enter and wait. Okay, now it loads the kernel. Okay, so now we go into post-installation system deployment phase or application deployment phase, where we basically install the software that we're going to be using in this machine, the domain specific application that is. So I'll go through with it shortly after we get the system loaded. Might take some time. Yes, nice. Okay, we have the FreeBSD system ready here. So very first we have these virtual consoles which you can change into and out of by pressing Ctrl, Alt, and then the function keys. F2, Ctrl F2, Ctrl F3. As you can see, the TTYVN changes depending on which console we are in. And the very first TTUYV0 is special because if there are kernel messages, they will be rolling all over the screen. That is how the system console is normally set up. So I normally want to leave this first screen free, so I can come back here and check any kernel messages if there are any. And this is why I'm going to open the Ctrl F2, the second virtual terminal, and then log in as root. Okay. We're using the TCSH, the C shell, which is a garbage shell. We'll be replacing the shell with another soon, but the best way to do this is to actually install screen bash and then the sudo utility, and then add the bastard operator from hell user to wheel group, and then configure the wheel group so that it can use sudo to run programs with root privileges. So we will be doing that right now. Alright. Actually, I will be also installing a decent editor. The normal V editor that is included with FreeBSD is usable, but it's very cumbersome compared to the more modern alternative. If I would want to edit some system files, I could also use edit, which is the FreeBSD user-friendly editor. Let's see the rc.conf file, which is the system boot up configuration file. This is like autoexec basically. Okay, so here we have the edit editor. I can go and write stuff if I want to. Currently I really don't need to write anything here, just add one extra line and ESC key to go to main menu, and then choose a leave editor, enter save changes. That's how you change these things. The other way of changing things is the sysrc, which you can use to dump non-default system variables, or I can set something like foo, sysrc foo enable. Yes. And now I can see that I have the foo enable yes in the list. So, and I can also use the sysrc to delete these variables. Yes, we can use -x. So now we just enabled a dummy variable that does nothing foo enable. That would actually cause an error because there is no such service as foo. So we can use sysrc -x foo /enable. And now we don't have that there anymore. The sysrc utility is pretty good for modifying the rc.conf. In the future I'm going to make my own utility that not only enables you to edit the sysrc files but also the bootloader file. The bootloader file has a similar config which is somewhat different. There is no scriptable utility to edit it as far as I know, so I might be making my own shell script to do that. It's just shell scripting, it's fun, and you know. Okay, so what was I going to do next? Yes. We are going to update the base system. To update base system, we use the command FreeBSD update. First we need to fetch the update, so we use the subcommand fetch. And then we use two AND signs, like this, to signify if FreeBSD update fetch succeeds, then run the next command after me. Okay, that is what it means. Learn shell dialect, you will also understand this. The next command that we will run after FreeBSD update fetch is FreeBSD update install. If you run these two commands at once, you can get your FreeBSD base system updated. The reason why I'm talking about base system instead of system package collection like I would be talking in Debian is because FreeBSD base system is a monolithic image. It's basically at this point it is very monolithic for legacy reasons and for the reasons that to update a monolithic base system is fast because you can do it with patches. As you can see here, the updater is very fast because it doesn't need to download entire software packages. It can either download individual files or patches, as you can see here, specific patches to specific files. This saves a lot of bandwidth and time. Right? In Debian, if you wanted to update your Linux system, you would have to download, even if you had just the base system of Debian, you would have to download each package separately, which could be dozens of megabytes. Here we only have to download a few hundred kilobytes, probably, depending on the size of the patches, and then apply those patches to the files that are to be updated. This mechanism is made so that the base system is updated separately from packages, because even if you don't have up-to-date packages, you at least want to have an up-to-date base system. And base system updates being fast and conserving bandwidth is very important, because you want to do that every fucking day. Okay, right, so here we see following file be removed as part of updating. We can press Q. Following files be added, we press Q like Quebec. And following files will be updated as part of updating to Now it's installing updates. Alright, so I do have a kernel mouse, as you can see. I can move the mouse cursor, so I'll be using it to highlight some stuff here. Anyway, now we can see here that it's finished installing updates. And we can also see that the kernel image was updated. So we have some hardware specific driver changes and whatever. When this happens, we definitely want to reboot the system so we get to boot into the new kernel. So, sorry. To do that, we'll just run the following command: shutdown -r now. This means shut down by rebooting and do it now. Okay, press enter. I can actually remove the USB stick. I won't need it anymore. Alright. And press enter. There's a timeout delay of some like 10 seconds before it boots into the system. You can press enter to skip the delay. And you can use the /boot/loader.conf file to configure the output delay if you want. I will show how to do it later, but for now we'll do with the defaults.